Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. Let's apply the limit laws to evaluate the limit of this given radical function. So we are given here with this expression the limit of the square root of a rational function y squared minus 9 over 2y squared plus 7y plus 3 as y approaches to -1. Now don't be confused why we used y here instead of x. As long as the variables found here is the same as this variable here, we can still evaluate that. But if it's in the case, say for example, just what if this is x, so we cannot evaluate that because we don't have x variable there. Okay, so let's try to evaluate this. Let's have two different steps here, the longer one and the shorter one. I'm just going to present you two methods so that you could compare later on which is more applicable to you. Of course, probably some of you will pick the shorter one, but it's also important for you to understand the idea of the longer one and that they have the same results to appreciate the shorter one. So this is, we can do it like this. We can place the entire expression, the limit of y squared minus 9 over 2y squared plus 7y plus 3 as y approaches to -1. This is by the power, limit theorem for a root of a function. Then we can separate it like this, the square root of the limit of just the numerator minus 9 as y approaches -1 all over the limit of the entire denominator, 2y squared plus 7y plus 3, okay, as y approaches -1. Then we apply here, okay, let me use these portions here, apply the other limit theorems, specifically product, sum and difference, power, okay. So for numerator, you have the limit of y squared as y approaches -1 minus the limit of 9 as y approaches -1 over, you have the limit of 2y squared as y approaches -1 plus the limit of 7y as y approaches -1 plus the limit of 3 as y approaches -1. Then just simply apply the power and the product. So you have here the limit of y as y approaches -1, you square that, minus the limit of 9 as y approaches -1 all over. So this is the same expression here. We have the limit of 2 as y approaches -1 times the limit of y as y approaches -1, but you square that. Then I hope that we have spaces here. The limit of 7 as y approaches -1 times the limit of y as y approaches -1, okay, plus of course the limit of 3 as y approaches -1. Sorry, I don't have much space. Let me move it here. Then we can now break all of them. You have -1 squared minus the limit of the constant is the constant itself over, you will have here the limit of the constant is constant itself, limit of the identity is -1 squared, plus limit of the constant is 7, limit of the identity is the value of c, plus the limit of the constant 3 is just 3. So I still have space here at the bottom. Okay, let me move it here. So you have the square root. The square of 1 is 1 minus 9. Okay, so over, you have 2 times 1 minus 7 plus 3. So you have the square root of -8. You have 2 minus 7 plus 3. This is square root of -8. Our denominator, don't worry about the -8 there because our denominator we have -2. Right? So we could have the square root of +4 as we cancel that. The answer here is 2. This is the limit of the given function. Okay? But this is very long. As you can see, it's very long. We can just simply use this method of direct substitution since we already have established ideas of this on this when we discuss the limit theorems before. 7y plus 3 as y, sorry, it's y approaches negative 1. So we have here, okay, so direct substitution, negative 1 squared minus 9 over 2 negative 1 squared plus 7 times negative 1 plus 3. As you can see, this is just the same as this here. Okay, they're just the same. So probably we'll have the same result. Square root of positive 1 minus 9, 2 times 1 minus 7 plus 3. Square root of negative 8 over 2 minus 7 plus 3. Square root of negative 8 over negative 4. Sorry, negative 2. Yeah, negative 2. Square root of 4, which will give us 2. We have the same results as earlier, using the longer method and the shorter method. Now it's up to you which to use, but definitely you already have your decision, but this is just to illustrate both of them. So what are you waiting for? Subscribe now!